Here's our final video on linear relations. Today we're going to be using interpolation and extrapolation to solve problems. Okay, interpolation is making predictions between given points, and extrapolation is making predictions outside of given points. Pretty easy to remember. You've got in for the ones between, so it's kind of inside what we've got, and extra is on the outside. So I think that's pretty easy to remember. Okay, let's have a look at an example here. First one, we're going to be using interpolation, so it's going to be between the points we were given. Okay, we've got Jenna that's borrowed some money, and she's going to be paying it back every week. Okay, so let's look at this graph and look at the questions. So how much money did Jenna originally borrow? So let's have a look here. They've given us 3 data points. At week 0, she owes $200. At week 5, she owes $100. And at week 10, she owes $0. Okay, well, if she's got a loan and she's paying it back, then at 0 weeks, this must be how much she borrowed in the first place. So she borrowed $200 to start with. Okay, and now we want to know how much she owes after 3 weeks. Okay, so here's 3 weeks here, between 2 and 4, obviously. And we want to figure out which point would go up here above 3 weeks. Well, let's take a ruler and have a look here. Actually, it's probably easier if I put the ruler on that side. And we can see that our points are in a straight line. So at 3 weeks, it looks like our point would be here. And that's going to be $140. And let's just think about that for a second. We know she's paying back money every week. So after 1 week, she owes $200. After 5 weeks, she owes $100. So she must have paid off $100 in 5 weeks, which means she must have paid off $20 a week. So after 1 week, she paid off $20. That would have been $180. 2 weeks would have been down to $160. 3 weeks would have been down to $140. Yeah, so that makes sense. Good. Okay, how many weeks will it take Jenna to repay 1/2 of the money she borrowed? Well, that's an easy one. They've already given us the point. We know she originally owed $200. And at $100, it's right here. So that's 5 weeks. Okay, D, should the points be joined? Okay, so you remember if we were to take our ruler and draw the line in here, it would mean that we would have infinite little decimal points in between all of the major points. So first, let's put in all the major points. We figured out that she's paying back $20 a week, so after 1 week, she's going to owe $180. After 2 weeks, she's going to owe $160. 3 weeks we already did as $140. 4 weeks will be $120, and so on. 6 weeks will be down to $80. 7 weeks down to $60. 8 weeks down to $40, and 9 weeks will be down to $20. There we go. Okay, so there's all our major points there. Okay, now we need to decide, are we going to join these? So do we have these little decimal points? So at half a week, would she owe $190? Should I have a point there at half a week? Well, no, because she's paying back the 20 every week. So no, we shouldn't join the points. So let's write no down there under D. And then it says complete the graph. Okay, this gets a bit weird. I think the person that designed this problem either didn't know or didn't care that this graph is basically harder than than what you guys are doing in Math 9. I'm going to go over it just so you guys are familiar with it later, but you guys should know you're not responsible for being able to do graphs like this. So basically, let's go back to half a week. How much does Jenna owe after half a week? Well, how much money has she paid back after half a week? Nothing, because she's not paying anything back until the end of the first week. So after half a week, she actually still owes the whole $200. So I'm going to put a point there, showing that she owes $200 still after half a week. And what's she going to owe after, say, a quarter of a week? Well, same thing. She's still going to owe $200. After 3/4 of a week, she's still going to owe $200. In fact, she's going to owe $200 right up until the point where she pays it and it goes down to 180. So right at 1 week, it's going to drop down. So we need to show somehow that we've got all of these points in here, so all of these infinite decimals in here. I'm going to draw a line in for those. Right up until we get to 1 week. The symbol we use for that is an empty circle. This basically says we're getting infinitely close to this point, but we're not including it. When I fill in a circle like this, this shows that we actually have a point there. So at 1 week, she's not going to owe $200 anymore. She's going to owe 180. And then all during the next week, so after a week and a half, she's still going to owe 180. That whole week, she's going to owe 180. Right up until the end, where she's not going to owe 180. She's going to owe 160. So at 2 weeks exactly, it's going to drop down. And we can just follow this pattern down here. Not surprisingly, this is called a step function because it looks like a set of steps. So here we go. Now what's going to happen at the end? So after 10 weeks, are we going to have the same thing happen, or is it going to be $0 until right before 11 weeks and then drop down? No, from 10 weeks on, Jenna's not going to owe anything anymore. So basically from there until the end of time, we'll put the arrow on to show forever, Jenna isn't going to owe anything anymore. And again, you guys don't need to know all of this step function stuff. You basically just need to be able to answer the questions on the left there. Okay, and again, reminder, this was interpolation because they gave us the points on the end, and we figured out some stuff in the middle. Okay, let's have a look at the next page. Okay, and this time it's going to be extrapolation. So we've got Maya running on a track. And we're going to assume that Maya is some kind of superhuman that continues to jog at the same average speed even though the distances are getting farther and farther. Okay, so notice our data here, the points we've been given, only go up to 1,200 meters. But they want us to make a prediction about 2,000 meters. So this one's extrapolation. It's going to be somewhere way up here. So one thing we could do is we could continue the graph. We could, get another set of grid paper and redraw this graph and continue it all the way up to 2,000. I don't think any of us want to do that because it's a lot of work. So what are some other ways we could make some predictions here? Well, one way we could do it is by looking at how long it's going to take Maya to go 1,000 meters, and then we could just double it because we've been told she's a superhuman that jogs at the same average speed no matter what. So 1,000 meters would be here. So we're going to follow that over to the graph. So our point on the graph here on the line for 1,000 meters is going to be right there. So that's 8 minutes, that's 9 minutes. So I'm guessing that's, I'm going to say that 1,000 meters is going to take Maya about 8.3 minutes. Looks like it might be 8.3, 8.4, somewhere in there. I'm just going to say 8.3. So if takes her 1,000 meters, or sorry, if 1,000 meters takes her 8.3 minutes, then 2,000 meters is going to take her twice as long as that. It's going to be 16.6 minutes. So that's one of our extrapolation guesses. Okay, the other way we can do it is to use addition instead of multiplication. Obviously, this time we used multiplication to double it. We could also use addition. So we could look at what the farthest distance we do know with Maya, so that's 1,200 meters, is going to take 10 minutes. So we know 1,200 meters is going to take 10 minutes exactly. And then how much farther is Maya going to jog? Well, she'd have to go 800 more to get to 2,000. So there's our 800 there. I'm going to trace that across to right there. And that looks like it's about 6.7 minutes. And again, I'm just kind of guessing here. So that would mean if we added those together, 1,200 meters plus 800 meters would of course be 2,000 meters. And that would take 16.7 minutes. Okay, so those are two good predictions. We figured it'll take Maya about 16.6, 16.7 minutes to jog the 2,000 meters. Okay, we're going to do B in a slightly different way. In this case, we want to figure out how far Maya is going to jog in 14 minutes. Well, if we can figure out how far Maya jogs in 1 minute, then we could just multiply that by 14. So if I look here, 1 minute, looks like it's a little over 100 meters there. This is pretty small though and tough to see. So I think it's going to be 1.1, 1.2, somewhere in there. Or sorry, I guess 110, 120 meters in 1 minute, something like that. But I'd like to be more exact because we're going to multiply it by 14. So if we're off by a little bit, it's going to be 14 times that much. Oh, we could also look at here. We know that Maya goes 1,200 meters in 10 minutes. Oh, well, yeah, if she goes 1,200 meters in 10 minutes, then that's going to be 120 meters per minute. Huh. And now if we know she's going 120 meters every minute, and it's 14 minutes, then it's pretty easy to just go 14 minutes times 120 meters per minute will give us, and I'm going to use a calculator on this, 1,680 meters. And notice, this is going to take a calculator or some long multiplication. If you wanted to, you could do B exactly the same way as we did A, where we could talk about, how far does she go in 7 minutes and double it, or we could figure out how far she goes in 10 minutes and then do 4 more. Okay, so 2 different ways you guys can do those. And you should be ready for your assignment now. Have fun doing that.